So we know how to name elements. We know we refer to the periodic table. We know how to name molecular / covalent compounds. Now we're going to work on ionic compounds. We already said that these result from the transfer of electrons. They're made up of a positively charged cation and a negatively charged anion, and they usually are a metal and a nonmetal. Ionic compounds are kind of the hardest to name because there's 3 sets of rules. This is gonna sound really annoying. Guys, trust me, once you do practice problems, once you get used to it, it comes very quickly, and we're gonna be doing this all year. So, naming ionic compounds. There's one set of rules for when we have main group metals and nonmetals. You might be like, Ms. Beglin, I do not know what main group metals and nonmetals are. Don't worry, I'm gonna show you. So, main groups are basically the towers on the periodic table. This is group 1, group 2, group 3, group 4, group 5, group 6, group 7, group 8. These are the main group elements. There are main groups on the periodic table. They're the groups that we're most commonly going to work with. Let's go back. So first we list the cation, which is a positively charged ion and usually a metal. Then we list the anion, which is the negatively charged ion and usually a nonmetal, and we change its suffix to "-ide". Here's the thing. We have to use something called the crisscross rule to balance charges and determine the ratio of cations to anions. Guys, I swear I'm not making this up. You can Google it. It's got a Wikipedia page. In order to use the crisscross rule effectively, you need to know the charges of the main group elements. So let's write that in. I'm going to change the color. I'm going to make it blue. All the elements in group 1 form cations with a positive 1 charge. All the elements in group 2 form cations with a plus 2 charge. All the elements in group 3 form cations with a, plus 3 charge. Group 4 doesn't really form cations or anions. All the elements in group 5 form anions with a -3 charge. In group 6, we form anions with -2 charge. And in group 7, we form anions with a -1 charge. In group 8, again, we don't form cations or anions. So let's say I have NaF. I got to figure out what that is. Well, if I look at the periodic table, I find that Na is sodium and F is fluorine. I'm going to change the suffix on my anion, my nonmetal fluorine, to "-ide, and I end up with sodium fluoride. I don't need prefixes to tell me how many there are of each because I know that the sodium cation always has a +1 charge and the fluorine anion always has a -1 charge. We crisscross the charges to get the subscripts, and we get that for every 1 sodium, we need 1 fluorine. Again, I don't expect you to walk away from this video with perfect mastery. We're going to build this skill throughout the course of the school year, but this is a really good introduction. All right, so I want you to take 4 minutes and write the formula for the following ionic compounds. So I'm going to put 4 minutes on the clock. I'll see you guys in 4 minutes. All right, scholars, welcome back. Let's review these together. Okay, so potassium bromide. I know, and I can know by looking at the periodic table, that the symbol for potassium is K, and the symbol for bromine, which is where the word bromide comes from, is Br. I also know, based on their groups in the periodic table, that potassium forms a +1 charge and bromine forms a -1 charge. I'm going to use the crisscross rule, where the other species charge becomes the subscript to get, for every 1 potassium, I need 1 bromine. And of course, we just omit the 1s. So we write this as KBr. Let's move to calcium oxide. I know from looking at the periodic table that the symbol for calcium is Ca. The symbol for oxygen, which is where the word oxide comes from, is O. I also know from their groups that calcium always forms a cation with a +2 charge, and oxygen always forms an anion with a -2 charge. I use the crisscross rule to balance my charges, and I find that for every 2 calciums, I need 2 oxygens. But whenever we write chemical equation or chemical formulas, we use the simplest ratio. So 2 to 2 is equivalent to 1 to 1. So really, for every 1 calcium, I need 1 oxygen. And this is my formula for calcium oxide. Barium sulfide. Barium is Ba. Sulfur, which is where the word sulfide comes from, is S. I know that Ba has a +2 charge, and I know that, oops, actually I should check that one out. Yep, barium does have a +2 charge. And sulfur also has a -2 charge. Use the crisscross rule, and I get Ba2S2. We, of course, reduce our ratios, and I get BaS. And finally, magnesium nitride. Magnesium is Mg. Nitride comes from nitrogen. Magnesium always has a +2 charge, whereas nitrogen always has a -3 charge. Apply the crisscross rule, and I get Mg3N2. And I can't reduce that, so that's my formula for magnesium nitride. Okay.